All right, here we go. This is the practice test of Unit 10. And so we begin with this problem right here. So the first thing that we are going to need to do is develop our differences, which will be x1 minus x2. And we also need to get those average differences, which is the sum of those differences divided by the number of numbers. Okay, so I initially set up my calculator by putting x1 into my calculator as list 1, and then I take x2 and I put that in my calculator as list 2. So ultimately, this difference right here, which is x1 minus x2, is list 1 minus list 2. Okay, I'll need this in my calculator for future calculations, for instance, when I find this average difference. And so what I'm going to do is I'm going to take that list answer and store it as list 3. So my differences will be stored as list 3. So take this list right here. Okay, so if my differences are in list 3, this next formula is the sum of those differences. So that'd be the sum of list 3. And then you need to take that and divide by the number of numbers. In this case, that happens to be 6. All right, and I also need that in my calculator, so I am going to store that as the letter A for average. So my D bar is going in my calculator as the letter A. So let's go ahead and set this up and accomplish those two little pieces of information right there. So if there's stuff in your calculator, let's get rid of it. So here we have 59, 62, 54, 61, 72, and 63. Oop, I said 63. All right, 17, 16, 54, 62. All right, and then we have 60, 64, 52, 65, 75, and 63. 75 and 63. All right, 63, 65, 63. Okay, looks good. Okay, so as I was just kind of explaining, I find those differences, which is x1 minus x2. All right, I save that in my calculator as list 3. And then I find the average of those, so I add them up. And divide by the number of numbers, which happens to be 6. And I store that as letter A. All right, so the first real calculation that I have to do in this problem is to find this standard deviation, which is the sum double open at x minus x bar. It's the same difference. D minus D bar closed squared closed divided by n minus 1, okay, square root. All right, so again, calculator speak, what I'm going to do is this is the sum of D, sum double open of D minus D bar, closed squared closed, divided by n minus 1, which in this case is 5, square root that. That's going to be your answer. However, I need it in my calculator, so I'm going to store it as the letter S. Oh, so this is what I do for this part. So just following the formula, this is going to be the sum, double open of D minus D bar, closed squared closed, divide by n minus 1, square rooted. Okay, that's my answer, and I store it as the letter S. Okay, then I need to find my sample test statistic T, which is going to be D bar of S divided by the root of N. So that will be D bar divided by S divided by the root of N. Okay, so again, notice how I put my denominator in my own unique parentheses. So this is going to be D bar divided by S divided by the root of n. And that is our sample test statistic T. All right. Moving forward, we need a degree of freedom, which is n minus 1. N, again, in this problem was 6, so this is going to be 5. Okay, this is a two-tailed test. It says so right here. Also note that the alternate hypothesis implies this. This is a two-tailed with an alpha of 5%. This is, in essence, going to be affecting my p-value that I'm going to be finding right here. So let's go ahead and find this p-value, keeping in mind that, yes, this is a two-tailed. Okay, this is going to be built upon the answers that we just got, which is a t of 1.5119 and a degree of freedom of 5. Okay, to get this p-value and we have a t, we obviously look at the t-table. This is a two-tailed, so 1.5119. The degree of freedom of 5. Okay, so we obviously look at our t-table for this. Try that again. So we're looking at a degree of freedom of 5, and we're looking for 1.5119. And so it's going to fall in between 1.476 and 1.699. And so that's where it's falling. And again, this is a two-tail, so make sure when you go, you don't go all the way to the top, because they want this to be a two-tail, which happens to be in between 0.200 and 0.150. All right, so again, degree of freedom of 5, this would fall in between 1.476 and 1.699. Looking up to the two-tail, that would be in between 0.200 to 150. Those are your p-values. All right, so somewhere in between those. Okay, so yes, indeed, this is a two-tail with an alpha of 5%. Okay, so we see that technically this is a negative t-value, similar to a negative z. Z's and t's are in essence the same. And so if these numbers are negative, that implies this is occurring on the left-hand side of the picture. Not that it's a huge deal, but this is technically happening, you know, over here someplace. Okay, that's where it's occurring. But regardless, our p-value is drastically larger than our alpha. Okay, either one, they're drastically larger. That means the distance from the edge is way bigger, and so I see that my p-value falls way into that do not reject H0 zone. I'll just record one of them. Doesn't really matter which one. Okay, so I have a p-value that is greatly larger. So that affects everything else. So here we go. So we see that the p-value is larger than the alpha. That implies do not reject H0. All right, so H0 in essence is the answer that we're taking. Now, what the heck does that mean? Okay, sweet, we're taking H0. Look up in the problem, and that will tell you where this goes from here. So H0 is mu of b is equal to 0. I told you to think of mu of d as being x1 minus x2. Think of that. All right, so mu of d is x1 minus x2. So if mu x1 minus x2 is equal to 0, that means x1 is equal to x2. So what do we say here? Okay, this is the one where we kind of break from script and we have to put in the fancy answer of we are unable to determine a difference between. Or, excuse me, to prove, excuse me, prove. Okay, here is where you fill in this blank with what you're talking about. It's either going to be P, mu, or an X. Okay, so you would say the probability or the average. In this case, when you have an X, you don't say anything specific. You don't really, you kind of leave that spot blank. All right, if it's a probability, you have to say the probability. If it's the average, you have to say the average. Okay, so we go into now the description of what that would be, and this is the typing speed. And then we go ahead and fill in the rest, which is going to be 1 verse 2. Literally use those words. Not 1 or 2, but verse. All right, so category 1 is the new keyboard. Category 2 is the regular keyboard. One more time. Pretend like I wrote things before in my life. Okay, and so those are those. That's the writing prompt there. We are unable to prove a difference between the typing speed of the new keyboard versus the regular keyboard. Again, if that was like mu1 is equal to mu2, I would say we are unable to prove the difference between the average typing speed of the new keyboard, and, or if there was a probability, it'd be the probability of the typing speed, et cetera, et cetera. Okay, now we go on to the confidence intervals. Sigma and S. This one is a sigma. Red marker here. My margin of error is going to be ZC of sigma 1 squared divided by N1 plus sigma 2 squared divided by N2. So the only thing that I need to make this operate is the ZC, which only requires the confidence. So we have a confidence of 90%. So I look at that Z table, and there's that little box that's on the bottom, and that lets you know what the ZC is. So here we have a confidence of 90%, so thus the ZC is 1.645. Okay, so now I have enough information to actually make this margin of error. And I pretty much follow straight up what this formula is saying. So I go sigma 1 squared divided by N1 plus sigma 2 squared divided by N2. Okay, I need to square root that and then multiply by ZC. So here we go. We have sigma 1 squared divided by N1 plus sigma 2 squared divided by N2. Okay, we square root that and multiply by ZC. Let's try that one more time. All right. So yeah, that looks right. So our margin of error comes out to be 15.5123. All right, 15.5123. All right, now we go to our confidence interval, which is x bar 1 minus x bar 2 minus e, which is less than mu 1 minus mu 2 which is less than x bar 1 minus x bar 2 plus e. This middle part of mu1 minus mu2 stays exactly that, and we just find the answers to the two sides. So the left-hand side is going to be x bar 1 minus x bar 2 minus e. And the right-hand side is x bar 1 minus x bar 2 plus e. Outstanding. Okay, so what I notice about this is the left answer is negative and the right answer is also negative. So that means the middle piece, which is mu1 minus mu2, is negative, aka less than 0. So that implies that mu1 is less than mu2. So the average of 1 is less than the average of 2. When I'm describing this, do not pay attention to the title, do not pay attention to any of this writing that's above. What you pay attention to is the description is this X bar. So this is going to be the feet to stop. Category 1 is tire A, category 2 is tire B. I do not want to hear anything about stopping power in this answer. So the answer is the average of 1 is less than the average of 2. So the average feet to stop of tire A is less than the average for tire B. So I'm just describing what this is. So the average of A is less than the average of B. Okay, here again we have another confidence interval, but this one, our standard deviation is an S, a sample standard deviation. So our margin of error formula is going to change up just a little bit. So it obviously involves S's, not sigmas, but it requires a TC for this. So a TC, this requires a confidence in a degree of freedom. So the confidence is described right in the problem itself. This wants a confidence of 80%. The degree of freedom is a little bit more clever. What we do is we look at the two ends, and what we do is we take the degree of freedom from the smaller of the two. So the smaller of the two is this 18. Thus, the degree of freedom in this case is going to be 17. Now we have all the necessary information to find that TC. This is obviously going to be on the T table, and so we have a confidence of 80% and a degree of freedom of 17. So let's go to the T table. So we have a confidence of 80% and a degree of freedom of 17. So the T table is this one right here. And so where I'm looking to kind of help myself out is that little box right there that has DF/C. So the DF, aka the degree of freedom, is 17, and the confidence is going to be 80%. Is 80%. Okay, so where these things intersect is the TC. So those two things intersect at a value of 1.333. 1.333 is our TC. Okay, we now have all the necessary information to find our margin of error. So similar to what we did before, we can almost type this directly in. So I begin with the inside, so I'll take S1 squared divided by N1 plus S2 squared divided by N2. That is on the inside of the square root, so I handle that next. And then I ultimately need to multiply, in this case, by TC. Okay, and that will get me the margin of error there. So let's go ahead and do that. So we take S1 squared divided by N1 plus S2 squared divided by N2. So S1 squared divided by N1 plus S2 squared divided by N2. That is on the inside of the square root, so I go ahead and square root and multiply by TC. .8489. Okay, the confidence interval is the same as above, which is x bar 1 minus x bar 2 minus e, which is less than mu1 minus mu2, which is less than x bar 1 minus x bar 2 plus e. This middle piece remains mu1 minus mu2. All I do is I get the answers to the two sides. So the left-hand side is going to be x bar 1 minus x bar 2 minus e. And the right-hand side is the same thing, x bar 1 minus x bar 2, but this time it is plus e. Okay, the numbers are important, but actually what's a little bit more important is the fact that the left-hand side is a positive and the right-hand side is also positive. So what that means about this middle piece, again, which is mu1 minus mu2, is that it's positive, aka greater than 0. So that means mu1 is greater than mu2. This is the symbol for average. So the average of 1 is greater than the average of 2. Okay, again, just as a reminder, what I'm looking for to help my description is this. Do not look at that. Do not look at the stuff. Look at the x bar. Okay, so the x bar is in pounds. Category 1 is what? Canadian wolves. Category 2 is Alaskan wolves. So the average pounds of Canadian wolves is greater than the average pounds of Alaskan wolves. Okay, pounds doesn't sound very great, so let's go with the word weight. The average weight of a Canadian wolf is greater than the average weight of an Alaskan wolf. So the average, again, average is key. Use the x bar to help your description. So the average of 1 is greater than the average of 2. So the average weight, okay, of 1 is greater than the average of the last. I don't know if that's true or not, but so again, this is just a description of what this is saying. The average of 1 is greater than the average of 2. Okay, then we move on to probabilities. The first is a confidence interval of probabilities. So the first thing that we need to kind of figure out are these p hats and q hats. So recall that a p hat, for instance, a p hat 1 is r1 divided by n1. And a q is always opposite of a p, so a q hat is 1 minus p hat. So this is the concept, so let's go ahead and find our base information. So 13 by 47 is 2766. And thus the Q of that is 7234. All right, the next one is 39 from 84, and so that is 4643. And so that's going to be 5358. Excuse me, 5357, I'm sorry. 5357. Okay. Here we are asked to find a margin of error. So the margin of error in this is going to be ZC P hat 1 Q hat 1 divided by N1 plus P hat 2 Q hat 2 divided by N2. Okay, we do need a ZC to make this one work, so let's go ahead and obtain that. Again, to get a ZC, all you need is a confidence. So here we are straight up provided a confidence of 95%. So we look at that Z table for a confidence of 95%. 95% says our ZC is 1.96. So now we have all the information to get our margin of error. I'll kind of step you through the calculator process here just a little bit. Jeepers creepers. Getting all over the place. Oh no. Let's get that back. Okay. Okay. I thought I erased everything. That would have been awful. Okay. Here we go. So I'm going to get the inside of this square root. So that is going to be the P hat 1 times Q hat 1 divided by N1. And I'm going to add P hat 2 times Q hat 2 divided by N2. So that gets me the inside of that square root. So because it's on the inside of the square root, that's obviously what we do. We square root. So we square root that, and then that's the entire square root, which is multiplied with the ZC in this particular case. So let's go ahead and find this. So P hat 1 times Q hat 1 divided by N1 plus P hat 2 times Q hat 2 divided by N2. Okay, that's the inside. Okay, we square root that. Okay. Okay, we square root that and multiply that with the ZC, which is what, 1.96. Oakley dokley. All right. So here we go, we have this. So let's establish our confidence interval. Our confidence interval in the world of probabilities is P hat 1 minus P hat 2 minus E, which is less than P1 minus P2, which is less than P hat 1 minus P hat 2 plus E. Again, if you haven't figured this out by now, this is the exact same thing, but in the world of probabilities, because this would be X1 minus X R2 minus E is less than mu1 minus mu2 is less than X bar 1 minus X bar 2 plus E. That's the same thing, just probabilities. All right. Anyways, I digress. Let's go ahead and keep back to what we're dealing with here. And so this is going to be P hat 1 minus P hat 2 minus E and then the right hand side is P hat 1 minus P hat 2 plus E. Okay, what I notice about these answers is that they are both negative. They're both negative. So that means the middle piece, which is P1 minus P2, is also negative, aka less than 0. So that implies that P1 is less than P2. So what does that mean in words? Okay, again, do not pay attention to the title or the writing, etc., etc., etc. Okay, look at the R. The R is going to tell you. So errors, writer A, writer B. Errors, writer A, writer B. So the probability of an error from writer A is less than the probability of an error from writer B. so again, all I'm doing is I'm taking this and describing what as probability of 1 is less than the probability of 2. Okay, on to the last problem, which is the hypothesis testing using probabilities. So what we begin is with p hat, and this is p hat 1 is r1 divided by n1. So that's pretty straightforward. Here we go. So that's 1 to 3 divided by some kind of 0. And that comes up with 1640. The other one is 108 with 500, which is 216. All right. So now the next problem is to develop a p-bar and a q-bar. So make sure you write your formulas. So this is R1 plus R2 divided by N1 plus N2. So again, all I do in this particular problem is I make sure the top is in its own parentheses. So R1 plus R2 is in a parentheses, and I divide by N1 plus N2 in its own parentheses as well. Other than that, it's almost foolproof. So this is R1 plus R2 divide by N1 plus N2. All right, and then Q bar is again opposite of the P, so that's opposite of P bar, 1 minus P bar. Okay, now to the big formula, the big problem right here. And that is developing your z-score. So your z-score in this particular case is going to be P bar times Q bar divided by N1 plus P bar times Q bar divided by N2. This is in a square root of a denominator that is P hat 1 minus P hat 2. Okay, this is kind of easy to mess up if you try to put it all together at once, or if you don't know how to handle your order of operations. So pay attention, follow along right here. I begin with the very, very bottom, the inside. So I begin with P bar times Q bar divided by N1, and I add P bar times Q bar divided by N2. Okay, that is on the inside of a square root, so I go ahead and square root that. Okay, that is the complete bottom, so I can't take this divided by top, I have to take the top divided by the bottom. So I put the top in its own unique parentheses, and then I divide by this bottom. Okay, so the top being P hat 1 minus P hat 2. So this is how I type things into my calculator. All right, so the first one is the longest one, and so that's going to be P bar times Q bar divided by N1 plus P bar times Q bar divided by N2. Okay, that's the inside. I square root that. That is the bottom, so I have to take the top in its own unique parentheses, which is P hat 1 minus P hat 2 divided by this bottom. That is your answer. This is a z-score, so make sure you round to 2 decimal places. So negative 2.32. All right, I move on to the next problem that requires a p-value and a sketch. So my p-value is built upon the answers that I just got, and this is a z of negative 2.32. So I'm obviously looking this up on the z table and looking up negative 2.32. Now, always look this number up as a negative. Always as a negative. All right? Your resultant p-value will always be less than 0.5. So if you're getting numbers like 0.9, 0.6, point whatever, that it happens to be above 0.5, you're absolutely wrong. Okay, you have to look it up as a negative. Them's are the rules. All right, so the z-score is already negative, so I don't really have to be super duper careful. Just make sure you look it up on the negative side of the table, 2.32, or negative 2.32, I should say. So negative 2.32 is 0.102. All right, so 0.102 is that. This is a sketch left tail alpha of 5%. Sketch left tail alpha 5%. My p-value 0.01, 0.01 is way smaller than 0.05. So 0.01 has a shorter distance from the edge, so it falls into that rejection zone. So 0.102 is my p-value, which again is crazy smaller. It's like a fifth of the size. Okay, so that falls into the rejection zone. So what I notice about this is the p-value is less than my alpha. Whoa, alpha is that? It's less than my alpha. That means I reject H0 and accept H1. Okay, so in essence, we are taking H1 as our answer. So H1 is described right there. So let's go into that description. That means we're accepting H1. So H1 is saying PD is less than 0. Okay, so you'll recall that mu of D is thought of as x1 minus x2. P of D is thought of P1 minus P2. So P of D is less than 0. That means P1 minus P2 is less than 0. And ultimately, P1 is less than P2. So the probability of 1 is less than the probability of 2. Again, do not look at the title for information. Do not look at these words up here for stuff, okay? What you're doing is look at the R, which is the claims, and then group 1 and group 2, normal rate and reduced rate. So the probability of a claim at the normal rate is less than the probability at the reduced rate. So the probability of 1 is less than the probability of 2. All I'm doing is just describing the statement I just created.